Assalamualaikum and good day. I am Nur Nabila binti Rostam, a Bachelor of Science Physics from UiTM Jangka Pahang with a student number 2019-336543. A big thanks to my supervisor, Puan Syaadah binti Zainuddin. With her help, I could finish this final year project with the title Assessment of Radon Emanation Rate from Sand Brick used as building materials in Pahang using airtight chamber methods. There are 5 chapters in this study, which are: Chapter 1 is an introduction, Chapter 2 literature review, Chapter 3 methodology, Chapter 4 results and discussions, Chapter 5 conclusion and recommendation. Let us start with introduction, background of study. In Malaysia, sand brick are most used as building material because of its low cost and are easily to make. Materials that are used for buildings or houses such as the sand are rich with naturally occurring radioactive elements such as radium, thorium, and potassium. Indoor gas mostly exhaled from the building materials would contribute to the risk and pollute the environment if it is not controlled. Damages by the radon are due to how fast is the decay. Therefore, letting out a small but high radioactive of alpha particles and cause a local ionization that damage the cells along the lung that risk for cancer development. This is why a long-term exposure to the radon can cause lung cancer. But why did we specifically choose sand brick in this study? From previous study, we can see from this bar chart the concentration of radon in circular equilibrium in sand brick is the highest compared to other materials which are soil, sand, black cement, white cement and clay brick. All of these materials were retrieved in Pahang, Malaysia. Next is problem statement. Radon is the second main cause of lung cancer after smoking. It is also the main cause of lung cancer for people that does not smoking. Next is significance of study. Social awareness of indoor radon exposure are still very low. In order to prove how much radon emanated in the building for Malaysians to be aware, this study has been conducted by using airtight chamber method for a few months for a sample sand bricks from Mentakap, Kampung Awah, Jangka 15, Bandar Jangka and Jerantut Pahang. The concentrations of radon were increased with the age of the buildings. Therefore, to gain the information on how long the requirements on how to minimize the radon effectiveness, a lot of studies were conducted in different places and variations of building materials. Objectives of study. The aim of this study is to determine the assessment of radon emanation rate from sand brick used as building materials in Pahang using airtight chamber method. The objectives of this research are: first is to assess the radon concentration of the selected sand brick by using airtight chamber, and second is to assess the radiological risk of radon of selected sand brick in Pahang. Naturally occurring radioactive material, norm. Norm can be found anywhere such as from terrestrial and radiation of cosmic and naturally in states of gases, liquids and solids in radioactive materials. Solid state nuclear track detector such as CR39 is useful to detect radon or radioactivity. CR39 is used to measure the fission of nuclear, high-energy nuclear fragmentation, fusion plasmas, ray of cosmic such as radon measurement, and the fabrication of nanostructure. Next is Continuous Radon Monitor (CRM). Is a device designed to measure the rate of concentration of radon, and it is very sensitive. It is useful to measure the indoor radon, where it can measure the temperature, the humidity, and the pressure of the environment as well. Next is Radiological Risk Assessment of Radon. Radon is the heaviest radioactive gas and chemically inactive but can easily move in long distances through soil and rocks. Radon gas escapes to the atmosphere through diffusion, evaporation of soil moisture, and exhalation due to the change in temperature or pressure. And since radon is a single atom gas, it can penetrate through fractures and cracks. What is the effects of radon to human and environment? To human, in the air, Radon particles that combine with dust and aerosol will enter human respiratory system when inhaled, thus become the source of significant radiology exposure. To environment, radon is being transported to the Earth's surface through diffusion that can be found in groundwater and flows through rocks that rich of uranium and radium elements with high emanation coefficient. Samples, apparatus and instruments used in this study are Olympus optical microscope, CR39 and CRM. There are 4 preparations need to be done in this study. First is CR39. Firstly, we have to cut the detector into dimensions and put it into a cup. Make a hole in the cup's lid and seal the hole with a soft sponge, and lastly let the detector be exposed to the samples for a month. Next is the preparation for etching process. Etch the detector in a chemical solution of 6 mol of NaOH at 70 degrees for 4 hours and 20 minutes. Then, wash the detector with distilled water and dry it. Examine the detector under optical microscope with magnification 10 and measure and count the alpha tracks. Third is airtight chamber. First, we have to weigh each samples and place the samples in a plastic container. Seal the chamber tightly and put desiccant inside the airtight chamber. Lastly is the preparation for CRM. First, we have to weigh each samples, place the samples inside airtight chamber, seal the container with masking tape, and lastly retrieve the radon concentration data for every hour for 72 hours. Moving on to chapter 4, the result and discussions. First of all, about the CR39. The black dark spots can be seen on the CR39 detector, which represented the radon under an optical microscope with magnification 10. For radon concentration, both sample 1 and sample 5 shared a same lowest concentration. Meanwhile, sample 2 recorded the highest amount of radon concentration. In case of radon emanation rate, it is depending on the concentration of radon, which is why the highest concentration of radon means the higher emanation rate. Moving on to the result of CRM. We can see from this data, sample 1 recorded the lowest amount of concentration of radon, meanwhile 74 is the highest. As I mentioned before, the emanation rate of radon depends on the concentration of the radon in the sample. Since sample 4 have the higher concentration of radon, it also emanates the highest amount of radon. Radon came from radium, which is why concentration of the radon will be high if the radium content in a sample is high. In this case, we can see from the data, sample 4 recorded the highest amount of radium content. That is why the concentration of radon in sample 4 is highest among other samples. Moving on to the last chapter, conclusion and recommendations. Sample 1 that was retrieved from Mentakap recorded the lowest radon concentration and emanation rate for both methods. However, when using CR39 method, sample 2 that was retrieved from Kampung Awah recorded the highest radon concentration and emanation rate. But when used CRM, sample 4 that was retrieved from Bandar Jengke recorded the highest radon concentration and emanation rate. The problem that occurred during the study was time-consuming because it can measure only a single sample at a time. As for recommendation is to use energy dispersive X-ray fluorescence EDXRF because it has the fastest ways and effective in cost, besides of friendly user to the environment. Second problem is about the samples used as building materials aside from sand brick. So as for recommendation, we can use different building materials aside from sand brick like cement, marble or tiles that were used in Pahang using the same methods. That is all from me. Thank you.